Welcome to Blue Pen Land here. Let me just show you some tips for solving linear kinematics problems in free fall here. Okay, and these are things that are just always true. The acceleration is always, when it's in free fall, negative 9.8. So this is before it, of course, air friction becomes a problem, right? So this is neglecting air friction. Okay, so the acceleration is always negative 9.8 near the surface of our Earth. It's even 9.8 down, even at the top. It's still accelerating when the velocity is 0, right? And then the final velocity at the top, right? That's our final velocity. At the top is 0. Because if it's not 0, it's not at the top, is it? Right? It's on its way up or it's on its way down, right? And then if and only if you start and end at the same elevation, that is, you've got a situation where here's the ground and you go up, right, and then you go down. This is like the air rocket lab where we shoot the rockets up and down, right? Then we can say it spends half the time up and half the time down. So if it's in the air for 6 seconds, it spends 3 seconds up and 3 seconds down, okay? And then the other thing is that the final velocity equals negative the initial, okay? So if the initial is 29.4 positive, right, then it's going to hit the ground at negative 29.4 meters per second negative. Okay, so just write these down. These come in very handy. I'm going to do an example, and then I'm going to break the video at that point and do another example. Okay. But first, let's make a little graph here, a velocity versus time graph for an object thrown straight up, right, and landing back in my hand. Well, if we do that, you can think about this, right? Here's our axis, right? We started at positive 29.4, assuming I could throw it that fast. I don't think I could, right? And we end at negative 29.4, right? And it's got to go from there, while it's in the air, to there, right? Okay, here's 0 meters per second, right? So here it is leaving my hand. It slows down. It reaches the top right there. It comes back to my hand there. Here's where it left my hand. The positive velocity. Here's where it hits my hand again with a negative velocity. Okay, this is a little better graph here, right? So that's what it would do. There's the bottom. It's leaving my hand with a positive velocity. Here it is at the top where the velocity is 0. Notice it's 0 for an instant in time, the intersection of two lines, right? And there it is at the bottom, striking my hand again with some negative velocity, negative exactly what it started out with. So if it started with a positive 5 meters per second, supposedly, right, it would end with a negative 5 meters per second hitting my hand, if it's the same elevation, okay? I'm going to do 2 examples. You should watch the 2 examples. But let's stop this video right here.